So, hi everybody and welcome to the next episode of our webinar series, originally called Mittelstand Meets Open Source, which would translate to small and medium-sized companies meet open source. Today we decided to make the webinar in English, as we did with all the rather technical webinars, to make it easier for a wider audience. With me is Kai Hudalla from Bosch and Eclipse. Kai, hi.
Hi, everybody.
We will get a short introduction later on, but initially we had not planned to talk about Hono in our series because we are no experts in it. We know the project, we played around with it a bit, but we never used it extensively. So we decided that it's not such a good idea to talk about Hono. But as it was requested, I think in the Dito webinar, multiple people asked about Hono. So we decided to do a separate webinar on Hono and asked Kai, who really is an expert on Hono, to join us and to tell us a bit about Hono. So let me just load the short presentation I prepared, and yeah, then we start. We gave the session today the subtitle, The Ultimate Solution for IoT Connectivity, and Kai later on will tell us a bit what the exact aim of Hono is and why he thinks, or the community thinks, that Hono solves a lot of connectivity issues you may encounter in an IoT solution. If we look at our timeline, you see that we already crossed a lot of topics, and we are now really in the cloud area. And Hono is one of the tools, probably like Hawkbit and Wato, that will come in the next 2 weeks, that solves a problem that you may not even think about if you're still in the hello world stage. So if you just start with an IoT project, everything may be fine. You have full control over your protocols, over your devices. So you may ask yourself after the session, okay, why is this Hono thing so complicated? But if you are already in such projects or have experience from these projects, you may easily understand what problem Hono solves. So keep this in mind as a bit of context, that Hono really is something which is not necessary at the start, most likely, but you will come very likely in many IoT or IoT projects at a stage where you need something like Hono because you no longer have full control over the devices or over the transport protocols that will be spoken. So next slides, who are we? I am pretty well known now, and Kai will introduce himself in his own slides that he will start in a minute. So I think we're done with the short introduction and the context, and I will hand over now to Kai to give a real introduction into Hono, I would say.
Okay, thank you, Julian. Let's hope that I can manage sharing my screen using Demio. It's the first time I'm using this conferencing tool, so give me a second.
Yeah, in fact, while Kai is preparing himself. In fact, we were already in the room, I don't know, 10 minutes before, but instead of testing the techniques, we really discussed about Hono and use cases. But hopefully it will work.
Do you still hear me?
Yes.
So my screen is currently frozen, my browser window.
Excellent.
Yeah, great.
So yeah.
Sorry, can't do anything now.
Okay, excellent. So should I share the slides for you then, or?
Well, in any case, I would need to get back into this conference in order to see what you are sharing,
Yes.
Because I can't see anything.
I mean, you can just, if you copy the link to another browser window or something, it should. Okay, now he's gone. Yeah. While we're here together, perhaps let me share some words about Demio. There are things we like about Demio and things we dislike about Demio. And one thing I dislike about this all-in browser concept that Demio has is that sharing is a bit more complicated than it needs to be. And this is one of the reasons why we decided to move away from Demio. So the next webinar will still be in Demio, but the webinar afterwards will not be in Demio. As this whole webinar thing is still also a learning experience for all of us. So we are open for any suggestions about tools that work better or that are different. There are pros and cons, as with everything in life. A big pro is that participants only have to go to the browser page and can participate. But really, the downside is that this whole sharing thing, which is initiated by the browser and which is based on WebRTC, is not 100% mature yet, in my experience. But to fill the time a bit until Kai comes back, probably let me already talk a bit about what we will do after the presentation of Hono. As in every webinar, we prepared a little hands-on example. Oh, Kai is about to come back. Kai,
if you want to, I can send you the link to the Google Docs presentation.
Oh yeah, excellent. Just where do you send it in?
In the chat.
In the chat, okay.
So.
Okay, excellent. Okay, I have to ask for access, so you should get my request for access now. I can already start to share my screen with the presentation.
I have granted access. That should be it.
Okay, excellent. Let's see. Oh, yeah, excellent. So,
okay. So now the only question is if you are able to do this full screen, maybe?
Yes, I never used this tool before, so I have no idea.
Top right.
Ah, yeah. Okay, excellent.
Okay.
Oh, this was the wrong one. Okay, Kai. So just point me whenever I should.
Sorry for the inconvenience. Yeah, my name is Kai Hudalla. I work at Bosch.io. That is which is a small subsidiary of Bosch, and we are mainly dealing in technology for the Internet of Things, and we are also a strategic member of the Eclipse Foundation, and I'm quite involved in several Eclipse IoT projects there. And Eclipse Hono is one of them. For Bosch, this is the technical foundation for our commercial product, the Bosch IoT suite, which we use internally and for external customers to implement IoT solutions. And today, as Julian already told you, I will give you an overview of why we came up with it, what the purpose of the whole thing is, and what it does, what it provides to you, and how you can make good use of it. And with that said, we should go to the next slide. Okay, let's get started with a very simple question or example. How do you measure a temperature somewhere in, I don't know, in your production line environment, wherever, and plot a curve for it? So this is basically really the 101 of IoT, and everybody has an idea of how to implement that. So for example, one question would be, given that you have a connected device, what transport protocol do you want to use to get the temperature to the backend where you want to plot the curve? Next slide. So everybody had a protocol in mind, and the point is there is no right or wrong here. There are hundreds of protocols. You can use one of the standard ones. You can use a popular one like MQTT, HTTP. You can use more exotic ones, or you can even implement your own. And the point is, no matter which protocol you pick, there will always be others and additional ones, and you can now either opt for choosing a platform or choosing to support any kind of protocol, or you will always be very limited to what you can support. So for us, at least at Bosch, it was obvious that we cannot simply just say we only support MQTT, because we already have many devices produced by several of our divisions that use arbitrary protocols, so we wanted to be very flexible there. So if you want to go on. Next slide, yeah. So one choice for implementing this use case would be to use a Bosch XDK. This is a development kit which has, I think, 16 sensor dimensions on a little chip, and it has wireless connectivity. It's almost, yeah, it's the size of a pack of cigarettes, I would say. And then you could, for example, use CoAP over UDP to send this data into a server application running in the cloud. There you could use Eclipse Californium as the CoAP server-side implementation, and then you can receive the data and create a plot graph using HTML5 on a web page. Totally fine. Okay, next one. So another use case from our experience or from our world is, for example, Bosch Power Tools produces this drill here, this hammer. And one of these comes in at over 900 euros. So you can imagine that these tend to simply disappear at construction sites. And in order to tackle that problem, you might want to do something like the following. Next slide. So the idea is that you add Bluetooth connectivity to these high-valued power tools, and then you can connect these tools, you can pair them with your smartphone, and the smartphone basically serves as a gateway transmitting data into a backend where you can then collect the usage data of how these tools are used on construction sites and do some data analytics on top of that. Also very, very nice idea, and some of my colleagues are actually working on something like that. Next slide. Another use case, finding a parking space. In large cities like Berlin, where I live, for example, people drive up to 4.5 kilometers in order to find a parking space, and it would be nice if you knew where there is a free parking space up front instead of simply driving around until you find one. So there is this little sensor here that you can see here, which can be embedded into the ground at a parking lot, for example, or a parking garage. And then you can easily determine whether this parking space is occupied or it's free. And based on that information, you can then guide cars to these free spaces. Next slide. So in a parking garage, this could, for example, be implemented using a Modbus that you have on each level of the garage. You can attach that to a Cura gateway where you collect the data, send it via MQTT to Eclipse Ditto, where you have a digital twin representing each level of the garage or even each parking space. And then you can have your management application interacting with Ditto using its REST API and use the data. Also, nice idea. People are already working on that. Next one. So whatever you do, after some time, it's up and running, and you implemented your solution, and everything is easy peasy. It's cool. But now, when you start rolling this out, some concerns arise. Next slide. And this is what, for example, the participants of the Eclipse IoT developer survey, what they have concerns about. And you see, compared between 2018 and 19, the absolute numbers vary slightly, but the overall, you get the overall idea. And one of the biggest concerns are obviously security and connectivity. And so with every IoT solution that you tinker up yourself, you need to solve these issues again and again and again, because without them, your IoT solution will never be in production. You will never pass the POC stage. So can you go on to the next slide? So some questions that come to mind when it comes to security are, for example, how do you authenticate the devices? How do you make sure that the data that you receive in your backend actually originates from the devices that you have in the field and are not simply impersonations from attackers or whatever? So there are several options, and some of them are very easy to use. Username, password, everybody knows that. Token-based authentication is a little more advanced. And then when it comes to authentication as part of a TLS handshake, you really have to start knowing what you're doing in order to get it right. Go on. Another question is, like at Bosch, we produce over 1 million things a day. And if you, not every one of them is an IoT device, but more and more of them are built with connectivity being available from the start. And you can imagine that we need to make sure that we can actually handle this large number of devices in our solutions. So obviously scalability is of concern. Next slide. And this affects both ways, vertical versus horizontal scalability. As long as you are dealing with enterprise scale, which from my point of view is, if it's about 10 to 20,000 devices, something like that, you can get away with just vertically scaling out, meaning you just use a bigger machine in order to handle more devices. But after some time, when you start getting into cloud scale, where you have millions of devices, you need to start about thinking scaling out horizontally. And that is, from a technology standpoint, you need to apply different patterns than what you do with vertical scalability. And so again, you can start solving that over and over again in your IoT solution. The point, however, is it doesn't really make sense to do this over and over again for each application, because the value that you generate in your IoT solution is usually not at this technical level, but in the level above it, where you implement the functionality, where you provide the service. Go to the next slide. So the question then is, how many of these technologies do you need to master? And my claim is, or the claim of Eclipse Hono is just one. Next slide. In particular, if you can use Eclipse Hono because it provides a uniform API for interacting with millions of devices using arbitrary communication protocols. So the idea is that it abstracts away all of the specifics of these devices regarding their transport protocols. It then provides a northbound API, which is based on AMQP 1.0 for your applications, and your applications only ever need to interact with this API, no matter which device you're talking to. You always use a logical identifier for addressing the device, and then you can send messages to it and receive data reported by it. Next slide. One of the fundamental beliefs that led us to implement it the way it is that there are two data streams in IoT applications. And the example I gave at the beginning, for example, is a typical example for the telemetry direction, meaning the things out in the field periodically send some data back to the cloud where you process the data. There are also use cases, of course, where you send some commands or control messages to the devices from the backend, for example, in order to configure the frequency at which they should, for example, report the data, or to turn it on or off, or whatever comes to mind. The point is, the telemetry direction, from our experience, is usually orders of magnitude larger in volume than the other direction, and also has different quality of service characteristics. The telemetry direction is optimized for throughput, so you need to scale out with the number of messages that are sent in parallel by multiple devices. whereas the command and control direction is more optimized for reliability, meaning it is important that a message actually reaches a device. In a telemetry case, for example, if you report temperatures every 10 seconds, it doesn't really matter if you miss out on one or two messages, because once you get the next message, you can basically interpolate the missing data. That's usually not an issue. Okay, so this assumption here led us to some technical design decisions that we made. In particular, Hono supports using different technology for implementing both directions, meaning we can use technology that better supports the telemetry direction, and we can use other technology for implementing the command and control direction. As a user, though, you do not really have to deal with that. So next slide. So this is the overall concept that in one picture. At the bottom, you have the things in the field. They connect to the arbitrary so-called protocol adapters that come with Hono. So we do have standard adapters for HTTP, MQTT, CoAP, AMQP1, and you can also add your custom protocol adapter, meaning if you rolled your own communication protocol. Julian, would you mind going on mute, maybe?
Oh, sorry, yes.
You can also add your own custom protocol adapter. But again, the Northbound API is always the same and is based on AMQP 1.0 message exchanges. So that is where you implement your applications on top of, and can then just use Hono's API to interact with your devices. Next slide. A little more detailed look at the Northbound interface that Hono provides. We have basically three interfaces: telemetry, event, and command and control. Telemetry is, as the name suggests, for receiving telemetry messages from devices. The event API is for receiving events, meaning events are supposed to differ from telemetry messages by means of quality of service, whereas telemetry is usually sent with an at most once delivery characteristic. Events are delivered with at least once characteristics, meaning your application can actually expect to receive an event once it has been sent. And it might get a duplicate, but it at least gets it once. The main difference within the system is also that telemetry messages are only routed from devices to applications, versus events which are being brokered. So being brokered means they are persisted by the system. From when a device connects to a protocol adapter, sends an event, then Hono persists that event in a broker, and an application then later connects to the event API to receive these events and gets them delivered by the broker. With telemetry, it's different. If there is no application registered for receiving telemetry data for devices of a tenant, then those devices of those tenants cannot even publish telemetry messages to the protocol adapters. That, from our point of view, makes a lot of sense, because why would we want to process this data from the devices if there is nobody downstream who's actually interested in the data, who wants to receive it? So we can apply this kind of back pressure that we receive from the applications. We can forward that down to the devices via the protocol adapters. The third interface here, command and control, as the name suggests, is for sending commands to applications. There are two types of commands. You can send a one-way command, which is kind of a notification to the device where you do not expect a response coming back, and a request-response command where you send a command to the device and also expect a response coming back from the device. So the work that Hono does here under the hood is mapping these messaging patterns to the specific transport protocols that the devices use. In some cases, it's kind of easy because, for example, MQTT and AMQP is kind of bidirectional. A device can, for example, can publish messages to a topic in order to send telemetry data to the protocol adapter, and it can subscribe to a topic in order to receive commands. That's easy. In HTTP, however, you usually do not have this dedicated channel to the device. So we implement something like long polling for that, meaning when a device sends some telemetry data in a HTTP request, it also indicates that it would like to receive a command in the response. And if it does so, and there is a command to be routed to the device, then that command is indeed put into the response body that is then sent to the device, and the device can then process that command. Next slide. The southbound interface defines which services Hono itself relies on in order to implement its services. This is mostly the credentials, tenant, and device registration APIs. Credentials and tenant and registration is about metadata about the devices. So the device registration is about registering devices. So a device has a logical identifier. A device belongs to exactly one tenant. A tenant is the logical scope in which you partition your devices. And credentials, of course, are the credentials on record for the devices, which the devices need to provide in order to authenticate with the system. This is a pluggable architecture, meaning within Hono we mainly define these interfaces by means of AMQP 1.0 message exchanges. And then you can either implement your own device registry. That is particularly useful if you already have a system of record where you manage such kind of information, or you can use one of the implementations that come with Hono. So for the time being, we do have an example device registry, which is based on loading data from a JSON file from the file system. But we're also currently working on an implementation based on MongoDB and an implementation that uses JDBC, which you can attach to any JDBC supported database. Next slide. So if you use Hono in order to implement these use cases that we went through before, it might look like this. You have your XDK, which connects to the CoAP protocol adapter in Hono, and the temperature monitor uses the Northbound telemetry, event, and command and control APIs to get the data and plot the graph. Next one. Same here. Now the smartphone posts its data by HTTP to the HTTP protocol adapter, and the data analytics application uses exactly the same Northbound API of Hono. Next one. Same here. The Cura adapter now publishes data to the MQTT protocol adapter, and Ditto is connected to Hono's Northbound API to receive the data, update the digital twins, and your parking lot management application sits on top of Ditto as before. Next slide. So if you combine all of this together, then you immediately see the advantage that this produces now. You can connect all of your devices to the same connectivity platform, which is provided by Hono, and your applications are always built in the very same way. They are always only interacting with Hono's Northbound API. You never need to consider or need to care about the origin of the data, because Hono has already taken care of that by having authenticated every device that connects to it and authorizing the device to send the data. You can be sure that the system will be able to scale out horizontally once you start adding devices, and you can start mixing multiple device types which use different protocols for your application. So if you have started to implement your application for devices which only use MQTT, you now get for free the ability to add devices that use arbitrary other protocol adapters without touching your application again. Next slide. Yeah, we went through that as well. So you can start small. We do have a demo deployment which implements or which deploys all of the involved components in single instances. But you can then easily just increase the number of protocol adapters, for example, for each of the protocols. as you go, and depending on the number of devices that you want to connect. So you can start small and scale out easily using today's cloud technology. So how do you run that? Where do you deploy it? Next one. What we do in Hono is that we implement all the services as standalone processes, and we create component images, so Docker images, container images from them. These container images are available on Docker Hub, and we then created a Helm chart, which we host on the Eclipse IoT packages project. And this Helm chart can be used to either simply deploy Hono to any Kubernetes cluster that you have, either locally or on the cloud. Or you can use another package that we have, which is the Cloud to Edge package, which actually deploys not only Hono, but also Ditto on top of it and pre-integrates them with each other. In any case, you just use a Helm chart and use the Helm tool to install it to your cluster, which is basically a single line command that you issue. It's comparable to a package manager, if you will, for cloud deployment. I'm not really sure, Julian, are you going to show that later on as well? No, you have already done that, right? You just have deployed it already.
Yeah, we use the public sandbox instance.
Okay. Oh, okay. You don't even deploy locally. Okay.
Yes.
So in any case, you can use this Helm chart to deploy to either Kubernetes or OpenShift or any other variant of Kubernetes. We have people deploying to Azure, the managed Azure Kubernetes service, the managed AWS service. So this should be no problem. Next slide. The components that we deploy or that are also running in the sandbox, which what Julian is later using, is it looks like this. So we do have a single instance of the HTTP adapter, the MQTT adapter, and the AMQP adapter. We have a device registry running. This is the example registry that uses the file system for persisting data. We have an auth server, which is used to authenticate and authorize the traffic between the Hono components themselves. Then we have an AMQP messaging network, which is represented by the dispatch router and the Artemis broker there. The dispatch router and the Artemis broker are both Apache projects. And the dispatch router, as the name suggests, is used for routing messages, while the Artemis broker is used for persisting messages in message queues. So telemetry data is always only routed through the dispatch router, and while events are routed through the Artemis broker, where they are persisted as well. And then at the right-hand side, you have the solution tier where your applications basically live. At the bottom, you see a Grafana and a Prometheus instance. Those are used for monitoring the components. We will come to that in a moment as well. Next one. So in 2018 at EclipseCon, Jens Reimann from Red Hat, who's also a committer on Eclipse Hono, has presented the numbers that they determined doing their scale out and load tests. And I do not want to go into each detail here. The point, however, is that the numbers indicate that you can indeed scale out horizontally, meaning if you have more devices and more load, you can increase the overall throughput linearly by adding more instances of the protocol adapter. So if you have 2 HTTP protocol adapters, then by adding 2 more, you can effectively double the throughput that the system provides. Always assuming, of course, that your backend application is also able to handle the load, to handle the messages. So you need to scale out that as well. The point here is Hono is usually not the bottleneck, or you can adapt it to not be the bottleneck by scaling it out horizontally. So they tested that with machines with, I think, 64 cores and terabytes of RAM, and then they started to use up all of these resources for the protocol adapters and came to the numbers here. Next slide. Okay, so if you want to know what's actually going on inside of the system, then you usually use something like yeah, monitoring infrastructure. And what we do in Hono is that we, next slide, that we use the micrometer framework to provide metrics from all of the components. So all of the protocol adapters report a set of defined metrics, which you can also find in the online documentation of Hono. And then we use Prometheus to scrape these metrics from the components. And then you can easily build some dashboards on top of Prometheus in order to visualize the data. So everybody who is professionally running a cloud service, I think, is quite familiar with this kind of setup. This is a very common combination of tools that are in use here. Next one, yeah, this is an example dashboard that also comes with Hono. Here you can see the throughput, the values on the right-hand side, how many operations, how much data per second is going through the system. You can see how many messages have been successfully forwarded, the overall throughput, and you can see the failure rate. Yeah, so this is just an example. Of course, you would probably want to customize that to your own needs. Another question is, if you have such a service, in particular, if this is a managed service for someone, you also want to know what happened to my message. At least that is what happens in our real world experience every day. People connect their devices, then they send messages, and then the message does not arrive at their application. And then they call us and ask, where the heck is my message? Or what happened? Why didn't my application receive it? And that is where you want to be able to trace messages through the system. So if we go to the next slide, the point here is, in a microservice architecture, multiple services, multiple processes running on different VMs, for example, are involved in the whole processing chain of a single message. So the device sends its message to the MQTT protocol adapter. The MQTT adapter then asks the device registry whether it knows about the device, whether the credentials are correct. Then it forwards the data to the AMQP messaging network's dispatch router, and then the message eventually arrives at the northbound application. However, how do you actually track the message going through all of these components in order to find out where did it go wrong? And for that purpose, of course, you use a distributed tracing system like for example, Jaeger. That is what we use in Hono. Jaeger, however, is just the backend that all the tracing information is collected at and visualized. In Hono itself, we use Open Tracing, which is an API, an open source API for producing tracing information. And all of the components then can be configured to forward that information to, for example, a Jaeger backend, but you can also use Zipkin or other tracing implementations. That is up to you, as long as your tracing implementation has support for open tracing, which many of them have. And then once you set this up, you can answer these questions. And this is how a typical trace through the system then looks like. You can see horizontally over time, or how long it took to process a single message. And then vertically, you can see which components have been involved in the processing. And some of them are actually, some of the interactions are done in parallel, while others are being done sequentially. So for example, we can only forward the message downstream once we have successfully authenticated the device, of course. So there is a sequential dependency here. But as you can see here, you can easily track wherever a problem occurs, because any of these so-called spans, those are the individual ones horizontally, if any of them fails, it immediately will be marked with a red color here, and you would see, okay, at this point there was a problem, and then you can drill down into that particular span and take a look at the log that is attached to that span, where you would usually find the reason why this interaction failed. So for example, if the credentials do not match, you would simply drill down there and see, okay, credentials didn't match, wrong password. Or in this case, with the assert device registration here, if, for example, a device connects with an identifier that is not registered in the system, you would immediately see here, hey, there is no device with that identifier for that tenant register. And yeah, this way you can easily track down any problems that you have, and you can answer to your customer very easily what he needs to change or what went wrong with the message and where it got lost, basically. Next one. So what's next? What's coming up? Go on. Hono has been around for quite some time now. We've been working on it since 2016. Since earlier this year, we have released Hono 1.0.0, which in Eclipse parlay means it has stable APIs, and we now follow semantic versioning with the system. We're already doing Hono 1.3 now in June, meaning we have iterated a little, have added more features and stuff like that. We usually do a minor release every 3 months, and in between every 4 weeks, we create a milestone release, which you can use to play around with new features or whatever, but every 3 months we do a minor. Next one. So what we are envisioning in the future is adding more integration options. So a lot of interest has arisen around LoRa and NB-IoT. We are planning to provide or to implement tighter integration with some of the more prominent LoRa network providers, like, for example, the Thing Network or Actility, something like that. Then NB-IoT is something that is being pushed quite strongly from the telco providers. So the Deutsche Telekom, for example, have an offering in that area. The services or the devices that they use can, from our point of view, be easily connected to our co-op adapter. That is something that we want to do. Sigfox is another option. And in the back end, we want to more tightly integrate with Ditto and Hawkbit. And as I mentioned earlier, that is already done in the Cloud to Edge package that we are doing in the Eclipse IoT packages project. That is where we basically want to create a pre-integrated stack of Hono, Ditto, Hawkbit that you can install in one go using a Helm chart, and then play around with the technology and see if it works for you. Another thing is maybe adding Kafka to the picture. So currently we are using the dispatch router and the Artemis broker to connect the Hono system to the applications. We also are thinking about replacing that with, or as an option, replacing that with Kafka, so that the protocol adapters directly publish data to Kafka. So if you have an infrastructure or applications that are already consuming data from Kafka, that might also be a nice integration option for you as well. This is just an overview of all the technology involved and links that you can follow in order to get to know more about the technology. And I guess that's also the end of the presentation. And we have some time for questions as well.
Yeah, thank you very much, Kai, for this very interesting presentation. At least I learned a lot. Hope others as well. I think before going to the hands-on part, we can take some questions. If there are already questions, just type them into the form. And we'll try, or Kai will try to answer them. In the meantime, I will prepare my setup for the example. Okay, no questions so far. Then we just jump over to the example. Let me give you an overview of what we want to do. Basically, the setup we have for the example is what I show here in the slide. So we use Hono. As already pointed out, we do not set up a Hono environment by our own, but we use the instance which is provided by the project itself, because we want to focus on the usage and the APIs. So we use this already existing Hono instance, and then we want to use two different routes, basically, or two different protocols, the HTTP protocol and the MQTT protocol, to send messages via the telemetry endpoint. And we will see that they arrive uniformly, basically, at the AMQP endpoint Hono also provides a little command line tool to listen to these messages and to print them out. That's the easiest setup. This is, as all the webinars, the thing I show here are published also on GitHub, but we also share the link on the homepage. So let me share my screen now. So okay, now you should see my IDE. So what I provided, what I prepared is a little Python example, which basically follows the quick start example you can see on the Eclipse Hono homepage. Let me show that to you. So if you go to the Eclipse Hono project website, there is this quick start example, which we will follow, but I made a little Python script to make just all those commands and variables a bit more convenient for you. But we follow the command. So first thing we have to do is to download this Hono command line tool, which I already did. It's in my downloads folder here. So basically all the rest is done in this quick start tutorial. So what I do here, just to go through the tutorial a bit with you. First thing we do is we register a tenant. As Kai said, Hono is organized in so-called tenants, which are a logical unit where devices can be grouped into it. And what we do is, with the first request, we ask to create a new tenant. Kai, you can always correct me if I'm wrong. And we get in response a tenant ID, which we will use in the future. Then we will register a device in the tenant with the next example and get a device ID for the device which is registered with some pre-given device credentials. The next step is then to give the device. Oh no, it has no devices so far. So the next step is to give the device credentials. This is another HTTP API call which we do. So we give it a password, which is my secret password in this example, and then we should get the response 204, which means the password is set. Now we are ready to communicate with Hono, with the device ID, the password we have, and the tenant ID via arbitrary protocols. What we will do at this stage is to start a command line tool, which registers northbound, as Hono calls it, because, as Kai said, if there's nobody listening, I cannot send telemetry data. So my calls would fail. And what we will then do after the command line interface is started is we will first send a message via HTTP. So this is the endpoint /telemetry, indicates it's telemetry message, and we just set a message which has its content the temperature. So we've been following the example from the initial example from Kai, and we will also send transport HTTP so that we see which protocol the message was sent on. And if we use HTTP, then we will use basic auth, but with the credentials created above. So device ID and tenant ID is the name for basic auth, and the device password is set above. If this works, we get a response of 202. And the second thing we will do is to publish a message as same device, but via MQTT now. So the payload is a bit differently, just different temperature, and we set transport to MQTT. And here we also use username and password authentication for MQTT protocol with the same schema basically as above. So device ID and tenant ID is the username or the principal, and password is again the device password as above. This is basically all the script will do. But I thought it's a bit more convenient to do a little script than to have all those command line tools necessary. I can also, if it's interesting, Kai, I can also add it to the repository, or we can add it to the Hono page if there is some interest.
Yeah, absolutely. It would be great if you created a pull request.
Yeah. Then after this session, I will be officially at least have committed something to the project. Okay, so now I run the script. Perhaps one comment also. I use variables here for registry and all that adapters. So if you decide to set up your own stack, you can still use the script, but just change those IPs to your respective endpoints. Okay, I started the example. You should now, you see the output there. So it registered a tenant with a UUID, it registered a device, and the password was set. So I am asked now to start the Hono command line interface. For convenience, I already concatenate the right string. So all I have to do is to copy this line, start a new terminal window, and go to the folder where my jar is in. So now I simply paste in the command, press enter, and ideally the Hono command line starts up and registers to the right tenant. Okay, you see it registered at this tenant who ends with ACC0, which is the right tenant. So now I have somebody who is listening for my messages on this Northbound AMQP endpoint. So now oh yeah, sorry. I already tried to increase a bit.
Yeah, that's better.
Yeah. So now I can, I probably can even set two screens together, because now if I press enter here in the Python script, it will first send an HTTP message and got the right response code, and it sends an MQTT message. And on the Hono side, now I'm making it bigger again. On the Hono side, I hope you can see what's pushing it up. On the Hono side, I get multiple logs. First, it received the telemetry message from the device with the payload temperature 5 transport HTTP. So my HTTP call worked. And the next message it received is a message with content type temperature 17 and transport MQTT, so MQTT worked as well. So this is the very simple quick start example, but as already pointed out in the presentation from Kai, the really nice thing here is now that no matter if I have devices working with HTTP or MQTT, I can simply have my command line running here or my application, and it's totally abstracted away from me. I just get the message, and the transport is a field I added in just to show you that which protocol sent the message. Coming back to the example, it can be as easy on a very simple device as just doing an HTTP post request to just send my data away from the device, or if, for example, I have a device version controller or that already use MQTT, it's just a matter of setting the right host name and the right username password for credentials, and everything works together. So this is a very, very short overview, a very short demo how this works. You can read through it in all details on the Eclipse Hono page, where you get full explanation on how this all is working, and also not only telemetry data, but also event data. And you can also try out command and control, which I skipped for brevity here. Yes, but this basically sums up the little example I prepared, and really want to encourage everybody who is interested in to just download the Python script and execute it. And you will see how it works and can start play around with it or modify it. Yes, so this is basically what we both have prepared for you today about Eclipse Hono. And now I would be really happy if we get 1 or 2 questions, probably. Okay, no questions at all. Everybody either understood everything or is totally puzzled.
I guess.
Probably.
There's a question.
Yeah, there's a question from Heli asking if you can just use Java API.
So, if I understand the question correctly, it's about, is there a Java SDK basically that you can use, or client library that you can use to interact with Hono? Is that the question? Yeah. So there is a Java client library, indeed. I would not call it an SDK yet. We see that there is increasing demand for that. So one of our contributors is working on that to refactor the client library that we currently have into a full-fledged SDK. But yeah, there will be one for Java. We are probably not in a position to do that for each and every programming language that is out there. So for that, we hope or rely on community members contributing something like it if there is increasing demand for that.
Okay, thanks. Another question I may have, is regarding the whole device registry and authentication. Yeah, it's mostly authentication, not so much authorization. So you currently provide this implementation based on the JSON file, if I understood you correctly. And what else do you want to provide, or do you have any plans to integrate it, for example, with systems like D2, where you may also have some kind of roles or devices already?
We had been discussing this several times with the good folks from Eclipse Ditto. However, whenever we talk about it, we very soon come out at that it doesn't really make sense to have one device registry for both, because the type of information that is stored for the devices is basically disjunct. It's completely different. And also the type of access to the data is completely different. In Hono, for example, we basically always only refer to any data by its primary key, by the tenant and the identifier of the device. Whereas in Ditto, it is mostly about filter expressions, meaning you almost always try to apply a command to not just a single thing, but to a subset of the things, and you specify the subset of the things by filter expressions. So the kind of access is different. The query language that you need to support is different. So apart from sharing the underlying database technology, maybe there is really nothing in common there. The only thing that you might want to make sure is that you actually follow a pattern where the device identifiers you use in Hono match the thing identifiers in Ditto. But that is something that for now you need to make sure yourself by convention. In the future, in the cloud to edge package, where we provide Hono and Ditto in a pre-integrated way, we will also add a provisioning API in front of it, where you can add a thing, a device, and then the provisioning API takes care registering the thing in both Hono and Ditto, making sure that this naming convention is actually being respected.
Okay, thank you. Are there any other questions?
How does this interact with Hotbit? So right now, today, it doesn't, meaning Hotbit is mostly, in terms of software rollouts for us, Hotbit can operate on its own today. And depending on how you connect your devices to Hotbit, you either use or connect them directly using HTTP, meaning your devices once in a while periodically send an HTTP request to Hotbit and say, hey, hi, here I am. Do you have something new for me? That's how it usually operates. Or there is another mechanism in Hotbit that allows to integrate with existing device management systems. And that is something that we will implement, or that is already being implemented at Bosch.io, connecting Hotbit to the Hono Ditto stack. And with that integration, you will then be able to use Ditto and Hono to roll out software to the devices. Well, to be fully precise, not really rolling out the software itself, but managing the rollout process, meaning you can then indicate to a device by sending a command to it, hey, you have something new to install, please use this URL to download the artifact and then tell me about the progress you make during the installation process. So you can still use Hotbit to manage the rollout campaign and track the progress of the rollout overall and for each individual device. But the interaction of the control channel is then via Ditto and Hono for interacting with the devices.
So one question from my side. So you would use then Hono's command and control API to notify. Okay, excellent.
So this is also something that we want to put into the Cloud to Edge package. It currently comes with Hono Ditto pre-integrated, but we also want to put Hotbit into the picture, and that should also then be integrated with Ditto and Hono the way I just described, so that you can experience the full stack there. And by the way, this is exactly the technology that we use for our commercial product at Bosch.io. So we are taking exactly this technology and turn it into a commercial managed service. So that is what we actually provide on top of just the plain software. We are running it on a cloud environment, on a public cloud environment, and basically operate it for you if you feel that this is too much of an issue. Yeah.
Okay, do we have any other questions? If not, I think we're finished just in time, although we had some technical difficulties. One question, Kai, can we share the presentation you held?
Yeah, absolutely. However, I'm not really sure. I think I will need to configure a public link or something in my slides.
Yeah, you either configure it yourself or just send me the PDF, or I will convert it to PDF and we will...
PDF is okay, I will send you a PDF. That's probably it.
Yeah, this would be really cool, and we will also link it on our site and in the YouTube videos. Okay, then once again, thank you very much, Kai. It was very interesting for me. I learned a lot, and hope for everybody else as well. Then wish you a nice long weekend in Germany, and we will see us probably next week and discuss about Eclipse Hono.
Great.
Thank you. So goodbye, everybody.